All right, welcome. Today's lesson is section 5.5 and it's on inverse trig functions. So before we dive into how inverses work with trig functions, I just want to remind you of some key ideas that you are already familiar with when it comes to inverse functions. The first being if you do a graphical test to see if a function is one-to-one. So maybe you need to remind yourself if a function is one-to-one, both the function and its inverse are functions. So if you do the horizontal line test on the original function and it passes, then you know that the function is one-to-one, which means both the function and its inverse are functions. You could also do a vertical line test on both the function and a vertical line test on the inverse to see if it's one-to-one. That's just kind of an extra step, though, more work that you would need to do. Something else you should know, I guess I skipped number 2. Number 3 is the domain of a function is going to be the range of the inverse. And the range of a function is going to be the domain of its inverse. So in other words, if you have a function that's xy, its inverse is yx. And that's why the domain and range are completely inversed of one another when you look at it, the function versus inverse. I'm guessing you probably recall most of that. So we're going to now apply that to trig functions. So if you look at the graph for sine of x, and I just have the sine wave here without any shifts, if I asked you if it was one-to-one, you could do a horizontal line test, and clearly you're going through way more than 1 point. So no, sine of x is not one-to-one because the inverse would not be a function. So in order to evaluate the inverse of sine, you have to make sure that you restrict the domain in order to make its inverse a function. Now, technically, I could restrict the domain anywhere, but if you look at where I have restricted it in between these red dashed lines, if you do a horizontal line test just in this region, you'll always just go through 1 point, which means its inverse of this piece would be a function. Once I go beyond this point, then I'm hitting 2 points. So I chose to restrict between negative pi over 2 and positive pi over 2. I actually didn't choose that. That is the restriction that your textbook uses as well. So if I restrict my domain from negative to positive pi over 2, any angle I choose for the sine of x needs to be in that domain. Okay, so on a unit circle, pi over 2 is here. Negative pi over 2, remember you go clockwise for negative angles, is really at 3 pi over 2. So anything, if I kind of darken the region here, anything over here is legal to make the sine of x one-to-one. So in other words, on a unit circle, my angle choices have to be in quadrant 1 and quadrant 4. Nothing in 2 or 3. Okay, I will come back to this. Going on to cosine of x for the very same reason as sine of x. If I wanted to make this one-to-one, I need to restrict my cosine wave to make sure that the horizontal line test is being passed. So your textbook chooses between 0 and pi. Of course, you could choose any region, but I'm going to restrict my domain from 0 to pi because then when I do the horizontal line test in this region, it passes and makes the function one-to-one. On a unit circle, anything between 0 and pi, of course, is quadrants 1 and 2. So now if you look over here, you can see that domain restriction has to be anything in quadrant 1 or 2. Okay, the last one we're going to look at is the tangent of x. And obviously, if you look at the tangent, if I just restrict it to one cycle, I would be fine, and the tangent of x would be one-to-one. Again, that restriction would be negative pi over 2 to positive pi over 2. So if you restrict, just like the sine graph, if you restrict it from negative pi halves to positive pi halves, you will have angles in quadrants 1 and 2 that will make the tangent of x one-to-one. Okay, now I gave you that background information. You're actually going to be doing some quick work with inverse trig, but I gave you that information just to remind you the why, the how, between your decision making. Okay, what you're going to be doing with these, actually before I do that, just quick summary if you didn't write this down already. This is all on one page for you. Cosine is restricted to quadrants 1 and 2, and inverse sine and inverse tangent are going to be restricted to quadrants 1 and 4. on a unit circle, right? And the notation here also, remember, anything raised to a -1 power, that just means inverse notation. I want to, before I go on, very quickly tell you that when you're doing inverse sine and inverse tangent, being restricted to quadrants 1 and 4, you can't, to get to quadrant 4, you can't cross into the unrestricted regions. So I can't get over to 315 degrees, because when I do that, I'm crossing through second and third quadrants. So how else could you get to 315? By avoiding these quadrants, you'd have to go negative. So instead of 315 degrees, I could say -45 degrees, which is still in the fourth quadrant. So make yourself a note. Anything in the fourth quadrant when you're evaluating inverse sine or inverse tangent, these three key angles here are going to be -π/6, -π/4, and -π/3. So you need to write your answers as the red and not the blue when you get into inverse sine and tangent quadrant 4. And you'll see that as we look at a couple examples. So the notation you're going to see, you are familiar with doing this from the first couple days of chapter 5. So if I said, hey, where's the sine, or what is the sine of the angle 5π/3? So you would say, okay, 5π/3, that's in the fourth quadrant, and the sine value there is -3, -√3/2. Okay, so something you're very familiar with. Now, when you do the inverse approach, you're going to switch the side and the angle. So now you're going to say inverse sine rather than sine of the side. So now I'm going to say inverse sine of -√3/2. And now you're trying to find the angle. So you're trying to figure out where that angle occurs. So now you have to think about two things. Where is inverse sine restricted to? Well, it's restricted to quadrants 1 and 4. And the sine ratio being negative has to be then in quadrant 4 because it's not negative in quadrant 1. And to get to quadrant 4, I can't cross through quadrants 2 or 3. And so rather than being 5π/3, I would actually state that as, oops, and I have 5π/3. Sorry, that is wrong. Rather than being 5π/3, that would be -π/3. So this is wrong, sorry. It's -π/3 for that answer. We will do more. I apologize for that. Actually, let me just get rid of that, and I can certainly type in the correct answer for you. So again, inverse sine is restricted to quadrants 1 and 4, but you can't go through quadrants 2 and 3 to get there. So rather than saying 5π/3, you would say -π/3. All right, so here we're going to just kind of go through several of these. So I just have a unit circle here as reference. So the answer should be in radians for these. Okay, so when it says inverse sine of 1, okay, what does that mean? So in words, inverse sine of 1 means go to the restricted quadrant. Okay, so inverse sine is restricted to quadrants 1 and 4. So I only care about these two quadrants. And then this is really saying what angle has a y value, because sine is y, of 1. All right, well, if I'm restricted to quadrants 1 and 4, the sine is positive in quadrant 1, and 1 is positive, right? So now I know I'm in quadrant 1. And the sine value is y, and where is y1? That's at π/2. So then I know the answer is π/2. Okay, same thing here, inverse cosine of √3/2. So cosine is x. Inverse cosine is restricted to quadrants 1 and 2. So you're saying, okay, I'm going to go to restricted quadrants. Cosine is positive in quadrant 1, but negative in quadrant 2. So I've eliminated quadrant 2 because this is positive. And what angle has a cosine x value of √3/2? Well, you can see that cosine is √3/2 at π/6. All right, last one, inverse tangent of 1. Okay, so where is inverse tangent restricted to? Quadrants 1 and 4. And tangent is positive in quadrant 1, but not in quadrant 4. So I know I'm up to quadrant 1. And actually, there should be a negative there. Let's do a -1. Sorry. So tangent's restricted to quadrants 1 and 4. And where is tangent -1? That's going to be quadrant 4. Okay, and I don't have my tangent values listed on the unit circle, but you know tangent is 1 at π/4. So it's going to be negative 1 at 7 pi over 4, but I can't say 7 pi over 4 because then I'm crossing through the restricted quadrants. So instead of 7 pi over 4, I go clockwise and I say negative pi over 4. All right, you pause the video and try these three, and then we will move on. All right, so inverse tangent, restricted to quadrants 1 and 4. And what angle has a ratio of y over y divided by x of square root of 3? Okay, so it's positive, so I know I'm in quadrant 1 and not 4. And where is the ratio equal to the square root of 3? And that's at pi over 3. Okay, inverse sine, restricted to quadrants 1 and 4, but it's negative, so I know it's going to be quadrant 4. And where is y, sine, negative square root of 3 over 2, and that's at 5 pi over 3, but I can't say 5 pi over 3. I have to say negative pi over 3. And the last one, inverse tan, is restricted to quadrants 1 and 4, but it's positive, so I know I'm in quadrant 1. And in quadrant 1, the tangent equals square root of 3 over 3 at pi over 6. All right, adding on just a little bit, you might have to do a couple trig evaluations in one question. So this example says inverse cosine of cosine of pi over 3. So clearly you start with the innermost. So cosine of pi over 3, you know your unit circle. Cosine is x, so I go to pi over 3 and the x is 1/2. Okay, so now I'm doing inverse cosine of 1/2. And now inverse, you got to think about your restrictions. So cosine is restricted to quadrants 1 and 2. And it's positive, so I know I'm 1. And what angle has a cosine value of 1/2? And that would be pi over 3. So note, we just kind of started at pi over 3, ended at pi over 3, which doesn't always happen. You will see. Okay, second one, you're doing the inverse sine of square root of 2 over 2. So sine is restricted, right, inverse, to 1 and 4, but it's positive, so I'm in quadrant 1. Sine is the y-coordinate, and at pi over 4, the y-coordinate is square root of 2 over 2. Then I evaluate the sine of pi over 4, which again is square root of 2 over 2. Okay, last one, tangent of 2 pi over 3. Okay, so 2 pi over 3 is right here, and the tangent value of that, remember you do the sine divided by cosine ratio, or y divided by x, and you would get negative square root of 3. Okay, now I'm doing inverse tangent of negative square root of 3. So inverse tan is restricted to quadrants 1 and 4. And where is tangent negative? In quadrant 4. Specifically at what angle? At 5 pi over 3. But again, I can't say 5 pi over 3. I have to say negative pi over 3. So here's one where the starting angle and end angle were different, just to clarify. All right, last one. Maybe pause the video and give this one a shot. All right, where inverse cosine of square root of 3 over 2. So inverse cosine is restricted to quadrants 1 and 2, but it's positive in quadrant 1. And cosine is equal to square root of 3 over 2. Cosine is x, so that's pi over 6. And then you're doing sine of pi over 6. And sine is the y-coordinate, and that would be 1/2. All right, this one, you have the sine of pi over 6. So sine of pi over 6 is 1/2. And notice there's a square root of 3 out there. So it's square root of 3 times 1/2, which of course is square root of 3 over 2. Then what angle has a cosine value of square root of 3 over 2? So cosine restricted to quadrants 1 and 2, but this is positive, so I know I'm in quadrant 1. And cosine is x, and the x-coordinate is a square root of 3 over 2 at pi over 6. And there you have it. So inverse trig isn't too bad as long as you're comfortable with your unit circle. You're essentially working your unit circle backwards of the last couple days. So good luck and enjoy.